In the last video, we covered that the MCP registry has about 2000 servers built and ready to use. These includes GitHub, Postgres, Slack, Sentry, and more. But the moment you need your internal pricing API or your company's knowledge base, you are on your own. That's where this video starts. We are building a real MCP server from scratch, a search server using the Serper API that will wire into a LangGraph agent in upcoming videos. Stick with me for next 7 minutes. We will build a real server and I will give you 3 decisions that will save you a debugging session which you don't want to have. We need one package which is FastMCP, and this can be installed using pip. We are importing FastMCP from FastMCP package, and we are also importing requests. And that's how you instantiate the server. The name is what clients see when they connect and ask who they are talking to. Now we move to the tools. I'm defining my search tool like this. So this is the decorator that you use to define a tool. So let's talk about some decisions here. The first one is about docstring. People treat it as documentation, but this is not for humans. This string gets injected directly into the agent's context window as the tool description. It is the only signal the model has when deciding whether to call this tool or not and what to put in the query field. Write only search the web like just this much, and your agent will call it randomly and query it badly. You should write a proper spec when to use it, what a good input looks like, and the model uses it correctly. So you can see we have defined it search the web for current information about a topic. Use this when you need recent facts, news, or data that may have changed after the model's training cutoff. Do not use it for well-established facts the model already knows reliably. So basically you are giving it very tight prompt, and for the query you are saying keep it specific, like Tokyo population 2025, not just Tokyo. Broad queries returns low quality results. Decision is about raising exceptions. You see this block here. I'm catching the request error and just returning it as a string. I'm not re-raising it, not logging it or failing, and I'm just returning it. Here's why. Because an unhandled exception propagates through the MCP protocol as an error response. Depending on how your agent is configured, that can absorb the entire task. A string, even a failure string, lets the agent reason about what went wrong and decide what to do next. The agent handles search fail timeout. It cannot handle a crashed tool call. Decision 3 is transform at the boundary. So if you look at this block, I'm returning 3 clean title and snippet pairs, not the full Serper response object. The model doesn't need nested JSON with 70 fields. It needs information it can reason about. Transformation logic belongs at the server boundary, not in the agent. If you ever have 2 agents using this server, you don't want both of them parsing the same raw API response. Done with tool, which is our first primitive. Let's move to our second primitive, which is resource. Resource is read-only data the client can pull as context. It's not a function the model invokes. It's the data the host loads before the conversation even starts. Done. One gotcha worth calling out. Unlike tools, FastMCP doesn't always pick up docstring reliably for resources. So you should pass description explicitly in the decorator. If you skip it, the client lists your resource with the no description and the model has no idea what to do with it. Use resources for configuration data, reference content, or schema definitions, anything read-only that the client should have as background context. Here I'm giving additional context that these are the regions I want my Serper API to look into. Here, third primitive, which is prompt. I'm pasting some code here. These are the reusable templates the server exposes. My personal opinion is that you should put your prompt logic in the agent's system prompt instead, rather than adding it here, because adding it here adds complexity that you don't need. But there are use cases where you have to define the prompts here. They matter when your server is consumed by a VS Code or Claude Desktop or Cursor, where the host surfaces them as / commands for a human. Other than that, I think they should go in the system prompt instead. I'm including it here so the inspector shows you all 3 primitives in action, which brings us to testing. Let's add our main block. You can see that I'm using stdio for now. The server runs as a local subprocess. Let's start the server. Python The server is running, but here's the problem. It's waiting for JSON RPC messages over stdin. You can't just curl it. You can't open the browser and see what's going on. There is nothing to look at this stage because we don't have a client. And you are not going to wire this into an agent yet just to test if the tool works or not. That's the wrong order. You would be debugging through two layers. One is the agent, which is your client, and the second one is server, which is what we just developed, when the problem might be in either of them. What you need is something that speaks to the protocol directly, and that's the inspector. And that's how you start the inspector. The MCP inspector is just a developer tool that ships with MCP SDK. One command like this and it will spawn your servers as a subprocess, opens a web UI in your browser and gives you a direct line to the protocol. So the web UI shows the tools that are available, and in our case we have only search web tool. I'm gonna select it and it has some data here which defines the schema, the output schema. And it talks about the doc string that we added. It exactly matches that. And here's the query. So we are going to add the query now. What's the current population of Tokyo? And run tool. And it returned that search unavailable because Serper API key not set. So that error is graceful degradation working exactly as designed. The server did not crash, it did not throw an exception, it returned a string the agent can reason about. That comes from our decision 2 that we discussed, and now you have seen it live, not just in the code. That's our complete MCP server. There were 3 decisions that make a server production grade from day 1. First, doc string as API spec, not as human documentation. Second, the strings on failure, not exceptions. So you pass strings that agent can reason about. The third one is a transform at the boundary, not in the agent. You add some transformation at the server boundary. Get those right and you will never debug the wrong layer. This server runs fine locally on stdio. Take it to ECS and it breaks immediately because the transport is one decision that we always miss, and this is one of the most important that determines whether your server actually works in production or not, and that's what we are going to cover in the next video. If you found this useful, please subscribe to the channel. I'll see you in the next one.